This is the SOLIDWORKS design of a butterfly valve designed and presented by Gavin Cole, Owen Firth, and Savannah Penny. This is for the DFT 170 Fall 2024 Engineering Graphics class with instructor Dr. Hans Chapman. These are the reference images we used to design the parts for the final assembly. Figure 1 is a more detailed view of all of the components, while Figure 2 shows an assembled butterfly valve. This is our planning and sketching. Figure 3 shows how we divided up the sketching and modeling tasks, and Figure 4 shows the sketches of the lever arm and the second valve cover. These are our other sketches. Figure 5 shows the sketch of the valve housing and the screw, and Figure 6 shows the sketches of the valve shaft and first valve cover. These are the models for the housing body and screw. Figure 7 shows the model of the housing body, which used a lot of extrude boss and base, mirroring, and a lot of extrude cut to create. Figure 8 shows the screw, which was used multiple times in the final assembly. This part used revolve boss/base and extrude cut to create.
Figure 9 is the lever arm. The lever arm connects to the shaft in order to rotate the second cover. Figure 10 is the second cover. The cover is responsible for letting the fluid flow or stopping the fluid from flowing. Figure 11 is the valve shaft. This part was modeled mainly using revolved base and extruded cut. Figure 12 is the first valve cover. This part was modeled using extruded base, extruded cut, and circular sketch pattern. This is the assembly view. Notice the first valve cover in green holding the lever arm and the shaft together. This is our drawing document of the assembled valve. You can see the front, top, right, and isometric viewpoint of the valve. And this is the exploded view animation. Notice how the 3 screws hold the valve cover in place.
This is the assembly simulation. It shows the yield strength of the second valve cover, which holds back the fluids attempting to pass through. The valve cover withstood 500 newtons of force, making it ideal for withstanding the pressures built up by the fluids. Figure 17 is the assembly animation. It demonstrates how the valve cover opens and closes to regulate the flow of fluids that pass through. As a team, the main takeaways were creating drawing documents, simulations, animations, 3D modeling, and last but certainly not least, teamwork. With these points in mind, we utilized tools such as mates in assembly, revolve base, extruded boss base, extruded cut, mirroring, and circular sketch pattern. Utilizing the tools provided to us by SOLIDWORKS, we were much more efficient in these aspects. Overall, we incorporated a multitude of design tools and clear, concise communication between team members to maximize efficiency.